So today we will talk about application domains with specialized quality requirements. So the qualities that we have discussed so far can be applied to any software system. But software systems are built to automate a particular application, and therefore we can characterize a particular software based on the requirements of the application area. So now we will identify four major application areas of software systems and examine their additional requirements. So the first one we are going to discuss about is information system. One of the largest and fastest growing application areas for computers is the storage and retrieval of data. So we call this information system, and its primary purpose of this system is managing information. Some examples are banking system or library cataloging system. So those are information system. So basically the system has a database and you will do transactions on the database. The transactions are actually a sequence of actions like insert, retrieve, update, delete, those kinds of operation on the database. So the first quality of information system is data integrity. So when software developers are dealing with information system, so they must have to be concerned with data integrity. Data integrity is actually the accuracy and consistency of data stored in a database. So if we simply say this, it's actually verifies that the data has remained unchanged or remained unaltered in transit. So we can achieve data integrity by using data encryption or data backup. Data backup is actually storing a copy of data in an alternate location. Or we can also do input validation. Input validation is it's actually preventing incorrect data entry, and or we can apply data validation. So in those way we can achieve data integrity. And the next concern of software developers in information system is security. Here security means information security actually means that it's protecting your information from unauthorized access or use. So that's security concern. And the next thing is availability. So data availability is basically an assurance that your system and data are accessible by authorized user whenever it's needed. So we can achieve this by using offsite backups or by using proper monitoring or virtualization. And next one is transaction performance. Performance in information systems are actually transaction performance, and the transaction performance is a number of transactions per time unit. A distributed system is a system whose components are located on different networked computers, which communicate and coordinate their actions by passing messages to one another. So they are actually the components are actually distributed in different networks, and they are communicating with each other for completing an action or completing a query of our end user. And the examples could be if we give practical example, that's internet, or we can say Facebook is a distributed system software now. And if we can also say client server system or peer-to-peer system, those are also distributed system. So one of the basic characteristic of distributed system is partial failure. So what is partial failure? Suppose you have a network of 100 nodes. So if one of the nodes failed, but still your software or your system will work because the 99 nodes is up. So this is called partial failure. And here they have used a term fault tolerance. A fault tolerant design actually enables a system to continue its intent operation, possibly at a reduced level, but it will not fail completely. It can still work. Some of this part of the system fail, but the entire system doesn't. The entire system can still carry its operation or work, but maybe possibilities it will do it at a reduced level, but it will not fall entirely. So that's called a fault tolerant system. So distributed system is actually fault tolerant system. So that's why we use distributed system to make it fault tolerant. But one of the important goal of a distributed system is to construct the system in a way such that it can automatically recover from partial failure without seriously affecting the overall performance. So that's one of the goal in distributed system. And there are also other concerns in distributed system, like security concerns, as they are sharing the files with each other. So security is a concern over here. So the next one is scientific application. So scientific application actually simulates real world activities using mathematics. So real world objects are turned into mathematical models and their actions are simulated by executing the formulas. So yeah, computation, it's actually computation oriented. So for example, an airplane's flight characteristic can be simulated in the computer. So that's a scientific application. Even rivers, lakes and mountains can be simulated. So virtually any object with known characteristic can be modeled and simulated. And simulations are enormous calculations. So it's calculation oriented. And what's main quality concern over here? Of course, accuracy. In scientific applications, accuracy is the most concerned quality. So accuracy, we know what accuracy is. It's the closeness of result to correct precision. And the next one is real-time systems. So real-time system is it has a time bound. So it's a time bound system which has well defined fixed time constraint. So in real-time system, main issue over here is time constraint. Okay, so examples of real-time systems include suppose air traffic control system. That's a real-time system. So from here, like air traffic control system, what's the most important thing that we have to maintain here? Which is real-time response, right? So it should not be a fast response. We don't need a fast response. It should be verifiable response time. So while we work with real-time systems, that's one of the major concern, verifiable response time. And the next one is embedded system. So you know what embedded system is. Actually it's a microprocessor or microcontroller based system, and they are used to host of modern devices like household machines like microwave, oven, washing machines. Those kinds of things are embedded systems. So the softwares are mostly written in assembly language, and embedded system software can be defined as specialized programming tools in embedded devices that facilitates the functioning of the machine. So now what you have to ensure here in embedded system, the main thing over here is functional safety. Functional safety is the correct operation of a system or equipment in response to its input. So when functional safety has been made, the system has eliminated all unacceptable risk and poses no threat of injury to occupants. But unfortunately, as embedded system is extremely complex, it's difficult to mitigate all risk.